Vitamins. So vitamins are different from our macromolecules, and these are not macromolecules, but they're still needed in our diet. So what they are organic compounds, and organic compounds, they have carbon and hydrogen, typically oxygen and nitrogen as well. And then vitamins help enzymatic reactions. So these are ones that you need for normal physiological functions. And what's the difference between a vitamin and a mineral? Well, vitamins are organic. Minerals, these are inorganic. So there are things that don't include carbon, hydrogen, oxygen, and nitrogen. These are things like phosphorus, and sodium, potassium, chloride, the electrolytes as well. So vitamins are not macromolecules, so they're not carbs, they're not proteins, they're not lipids. But again, you still need them in your diet for normal physiological functioning. Again, minerals, these are inorganic chemical elements. These are not the ones that have the carbon and hydrogen. So here we have a list of all the water-soluble vitamins. This is in your slides and uploaded on La Lima, so don't worry about looking at this this video right now. But the thing is that vitamins, like a lot of them are water soluble, and if you look at the back of any sort of energy drink, well, you can see that they're chock full of these vitamins, and especially like the B vitamins, they often say like, okay, this is nutritious because we threw all these B vitamins in there. And if they weren't water soluble, then you would have these B vitamins floating around in your energy drink in this nasty sort of particulate. So the B vitamins are water soluble. And how about this? This is orange juice. And what vitamin is orange juice or are citrus fruits very rich in? They're very rich in vitamin C, right? So vitamin C is also water soluble. If it wasn't water soluble, then you would have like fatty clumps of vitamin C floating around in your oranges and citrus fruits, which doesn't happen. So B and C vitamins, these are water soluble. And there are many B vitamins, and the interesting thing is that when they were coming up with when they were discovering vitamins, they were like, okay, if you have a nutritional deficiency, then this is the way they were finding it. It's like, okay, if you have the way they discovered vitamin B is that they noticed that people who were eating who ate polished white rice versus the one with the hulls, they were starting to develop these diseases, and they thought they were basically had this extract they called vitamin B, and they saw that if they had that extract that was isolated from the bran from rice, that these people weren't getting the symptoms of vitamin B deficiency. And that's why it's sometimes called vitamin B complex, because it actually has all of these chemicals right here. But the thing is that when they started investigating that extract, they saw like, hey, there are subchemicals of these that have different effects. And this is why there are so many B vitamins, because it was originally a crude extract, but as they investigated vitamin B even more, they saw that it's actually made out of multiple different chemical compounds that are all important, but they have their specific chemical structures and effects. Now, how about the fat-soluble vitamins? So again, water-soluble are all your B vitamins, or most of your B vitamins, and vitamin C. And then you have A, D, E, and K. So then A, D, and K are the fat-soluble vitamins. My mnemonic, why am I showing avocados? The fat-soluble vitamins are K, E, A, and D. So my mnemonic is keep eating avocados daily. So that tells you all 4 fat-soluble vitamins. Now, why is it important to know the fat-soluble versus water-soluble vitamins?